Okay, hello there, and today I'm going to be talking through a vectors question from a past M1 paper. Now this is taken, it's question 1 from the Edexcel June 2010 Mechanics 1 paper. It's question 1, it's for 5 marks, and I'm going to explain how we answer the question and where the marks in the mark scheme are allocated. So the information that the question tells us is that for a particle P, it tells us it's moving with constant velocity minus 3i plus 2j. It tells us that when time is 6, the position vector is minus 4i minus 7j. And the question is asking for the distance of P from the origin at time t equals 2. Now to answer this question, basically we have to use a really big important formula in M1 vectors, which is written as follows. It's R is equal to R0 plus Vt. This is a formula that you have to know and be able to manipulate and understand and use. And what the formula basically means is that for any particle, the position vector at any given time is equal to its initial position vector plus its velocity vector times that value of time. So depending on the value of time, that will affect the position vector of the particle. And what I can actually do is use this formula straight away. So if I was to set the position vector at time t equals 6 equal to minus 4i plus 7j, I can substitute that in for my position vector. So I'm going to have minus 4i minus 7j. Now the nice thing here is this initial position vector does not have to be the position vector at time t equals 0. It can be the position vector of the particle at any time before time t equals 6. So if I was to set this R0, which we don't know yet, as the position vector of the particle at time equals 2, and then I could rearrange this formula to find this position vector. So remember, this is the position vector at time t equals 2. I'm going to add my velocity times time. So my velocity is 3i plus 2j. Now the time, it would be very easy to put 6 because this is the position vector of the particle when time is equal to 6. But because we have set the initial position vector at time t equals 2, then 4 seconds have elapsed since the particle being there to it being here. So I'm going to set my time equal to 4. Now if I was to expand and simplify this, I would have minus 4i minus 7j, same on the left side, and I'm going to have R0 minus 12i plus 8j on the right hand side. And rearranging this to get R0 tells me that R0 is equal to 8i minus 15j. So this is the position vector of the particle at time t equals 2. Now the question doesn't want the position vector, it wants the distance. So if this is the displacement, to find the distance we're going to have to find the magnitude of this vector. So to answer their question, the distance when time equals 2 is equal to the magnitude of this. So I'm going to square 8 squared and 15 squared and take the square root. If you plug that into your calculator, it will tell you that the distance when time is equal to 2 is 17 meters exactly. Now to give you an idea of where the mark scheme allocates marks here, for correctly using this formula you would get 1 method mark and an accuracy mark. Okay? And for successfully rearranging this to find the position vector of the particle when time is 2, you would get a 2nd accuracy mark here. And then knowing that you have to take the position vector and find the magnitude to find the distance, that is a 2nd method mark, and the final answer, correct as 17 meters, is the final accuracy mark. So that there is how the 5 marks are allocated. And the key thing really to answer this question is 3 points. You need to know this formula like the back of your hand. You can understand that the initial vector does not have to be the time at t equals 0. It can be at time t equals 2. That's just going to affect what number you substitute for t later. And finally, the key thing you have to remember is that for the distance, you're going to take the position vector and not stop here. You're going to take the magnitude of that to find the distance. Okay? Thanks ever so much for watching. I hope to see you sometime soon.